The next essential characteristic of cloud computing to cover is resource pooling.
This video is brought to you by EpiPies Academy.
Let's see how the NIST define this. The provider's computing resources are pooled to serve multiple consumers using a multi-tenant model, with different physical and virtual resources dynamically assigned and reassigned according to consumer demand. There's a sense of location independence in that the customer generally has no control or knowledge over the exact location of the provided resources, but may be able to specify location at a higher level of abstraction. For example, the country, state, or data center level. Examples of resources include storage, processing, memory, and network bandwidth. So let's have a look at this in some more detail. So the first thing to talk about that we can pool our resources for is the processor and the memory of the underlying servers that we're running virtual machines on. So let's go back to our hypervisor lab demo for this. So I'm back here in my VMware lab and in my management station, and this is similar to the kind of software that cloud providers would be using to manage their hosts and virtual machines. Maybe they'd be using VMware, or maybe they're using some other vendor's hypervisor, like maybe Citrix Xen Server. So I'm using VMware for the example here, and you can see in my lab I've got two hosts, 10.2.1.11, and I've got another host at .12. And I'm clicked on 10.2.1.11 right now and on the summary page, and you can see in this physical server that I'm going to be running virtual machines on, it's got two processor sockets, meaning it's got two physical CPUs and 2 cores per CPU. And I've got 2 gig of RAM in this server. Obviously, real world, in a real cloud service provider's data center, they're going to be using much more powerful hosts than this. I've just got a low powered host for my lab demonstration here. So those CPU and memory resources, that can be divided up amongst the virtual machines that I've got running on this host. So I can see I've got 3 virtual machines on here, OpenFiler 1, Nostalgia 2, and XP1. Again, these are just low-powered virtual machines for my lab demonstration. If I click on OpenFiler, I can see that it is running with 4 virtual CPUs and a little over 300 meg of memory. It's also using storage as well. It's got 100 gig of provisioned storage. That's going to be provisioned on my data store, which is living on my external SAN storage. If I look at Nostalgia 2, this is just a really small virtual machine that can be used to run old DOS games. So really it's for demo purposes. And it's got 1 virtual CPU, and it's got just 32 meg of memory. So you can see down at the underlying host server physical level, I've got the physical resources there, and then my virtual machines that are running on that host, they can get access to the underlying physical resources. It's the job of the hypervisor to make sure that the virtual machines get their fair share. In our cloud environment, very often we're going to have different virtual machines from different customers that are going to be running on the same physical server, and that's no problem. The cloud provider will make sure that we don't put too many virtual machines on any single server so they can all get good levels of performance. Also, security isn't a concern either. The virtual machines are kept completely separate and secure from each other. Okay, let's go back to the slides again. And the next resource we're going to look at that we can pool is the storage. So in my example here, I've got a storage system which is represented by the big blue box there, and it's got lots of hard drives inside that storage system. The hard drives are represented by each of these smaller white squares. With my centralized storage, I can slice up my storage however I want to and give the virtual machines their own small part of that storage for however much storage they require. So you see the example here on my first disk. I have taken a slice of that and I'm going to give that amount of storage to the boot disk on tenant 1, server 1. With cloud computing, we've got the concept of tenants. A tenant is a different customer. So customer A would be one tenant, customer B would be a different tenant. Because we can have multiple customers using the same underlying infrastructure, it's a multi-tenant system. Back to the storage system again. So I had my boot disk for tenant 1, server 1. I'm also going to take a slice of my storage and provision that as the boot disk for tenant 2, server 1. So you can see by having this shared centralized storage, it makes it really efficient. Rather than having to give whole disks to different servers, I can just give them exactly how much storage they require. Further savings can be made through storage efficiency techniques such as thin provisioning, where I can actually make it look to the servers like they have got more storage than I've got underlying physical disks underneath. I can also do deduplication, where if I've got duplicate data on the storage system, I can just keep one copy of it and I can remove the duplicate copies. That gives me more storage space. And I can also do compression, where I can get rid of repeating strings or white space in my data. If you want to find out more about centralized storage, SAN and NAS, I've also got another course on here, Introduction to SAN and NAS, and that will teach you all of the basics that you need to know about storage. Okay, moving on, the next resource that can be pooled are our network infrastructure and our services as well. If you look on the slide here, you see we've got a firewall up at the top. So that represents a physical firewall. Well, all of our different tenants are going to have firewall rules controlling what traffic is allowed to come in. If you remember the example before, we were allowing RDP for our management traffic. If it was a web server, we would allow web traffic on port 80 as well. Well, we don't need to give every single customer their own physical firewall. We can share the same physical firewall between different customers. Also, if they require a load balancer, say they've got a server pool at their front end and incoming client connections can hit any one of those servers, we're going to load balance those incoming connections across the different servers using a load balancer. Again, the load balancer can also be virtualized and shared between multiple customers. Also, in the main section here on the left, you see we've got multiple switches there, and we've got routers as well. Those switches and routers are shared. We've got traffic for different customers going through the same physical switches and routers. Over on the right hand side, the cloud provider here is also providing various services to the customers, such as Windows Update servers for the patching. We can also patch Red Hat from there as well, DNS, etc. So rather than having separate DNS servers for the different customers, we can provide DNS as a centralized service. So with all of these things, we have got a few underlying physical pieces of equipment, and we're running multiple customers through those shared pieces of equipment. Because we've got shared equipment, rather than having to dedicate a separate one to each customer, it means that we need to put less equipment in there. So we get economies of scale there, we get better efficiency, we get cost savings, and from the cloud service provider's point of view, we can pass those cost savings on to the customer, which makes it a more viable solution from the financial point of view. The last thing that I want to mention in this lesson, if I go back to the first slide and the NIST definition, you'll see they say that the customer generally has no knowledge or control over the exact location of the provided resources, but may be able to specify location at a higher level of abstraction For example, country, state, or data center. So what we're talking about here, let's use AWS for the example again. When I spun up a virtual machine, I did it in the Singapore data center because I'm based in the Southeast Asia region. That's closest to me. If I was based in the US, I would have chosen the nearest location in the US to do it. So by doing that, having it close to me, I'm going to get the lowest network latency and I'll get the best performance. So with AWS, you know the data center that it's in, but if we look at the last slide again, you'll see that within the data center, I don't know which actual physical server my virtual machine is on. It could be running anywhere in that particular data center. It could be using any of the individual storage systems that AWS have got in there. It could be using any of the individual firewalls. The specifics of it really don't matter to the customer. They're not important. As long as I know what data center it's in, the actual underlying server is irrelevant, really.